Recording live from Twitch, and looking back to last week, we had done a bunch of integration tests, and we've gotten some networking working. It was kind of a short week. I got pretty sick, but we're back to it. And one of the things we ran into was a couple of things that don't seem to translate over from hacked C++ to Erlang's socket stuff. Had to do with like the unsigned int, unsigned byte, and there was also like this strangeness with I think we put it under the util where it has like this 131, 97, 98, 110. They seem like completely random values. Well, in the Erlang documentation, this is actually the external term format, and it actually translates. It shows you like, if you're going to use 131. Means it's okay, that's a term, and then next byte is, if it's 80, it's going to be uncompressed size of zlib compressed data. So it knows how to operate when you actually translate the value. I'm going to take a look at this and see what we can use. Like here's one here with like 98. If we look at 98, it would be an integer, as you see there, like a 97, which we don't use. Oh, here, and there's 97. There's the byte. That's this one here, small integer. So it looks like there's some that aren't really supported. There's a float, 99. We don't use 99, so maybe that could be a clue to why our float was weird. And then our other one would be, I think it's this one, the 70. Let's see here, what's 70? 70, where are you, 70? No, 70 there. I guess I could just do a quick text search. Okay, so 70 is float, 8 bytes in big Indian. So that would be a double. And then 110 would be signed some sort of signed big int or big value. So I think this is what we're using for our double, I believe. So that's our float that we're using. So I wonder why we're using, what was 110? No, 70. Oh, that was our float. So that's not a big. So this is probably what we're using for our doubles and our longs. So I'm going to take a look at this. I was looking for something I found earlier, which was you can convert back to and from unsigned and signed specifically, and I can't seem to find it this morning. I thought I'd be able to find it again, but we're probably going to end up taking a closer peek into that. Anyways, we're just going to kind of continue on with our application, get some more tests in. We're going to try, well, the goal is to get 2 units moving in 2 different screens at the same time to show that our networking is working. Hopefully we can get there. But until then, let's keep our tests rolling, making sure our code quality stays very, very high. So we're working here. I should close socket. Should close socket not connected. So this is where we're working on our subscriptions. So should unsubscribe from socket closed. I think we have one that was actually pretty darn good up here, which is unsubscribe to socket connected. So here we're going to say subscribe to closed, connect to the socket, unsubscribe to closed, and there we are. And what we need to do is I don't think we need to technically connect, but we don't need that in there. We don't need to verify that. And we're going to assert our equal, or actually we just need to socket stream dot close. Then we unsubscribe from it, socket stream dot close. You're probably wondering, like, hey, like, if we close it, we're not setting it to false, which we probably should. So let's do this, and then should close socket. We should probably do a search is false socket stream connected. So let's make sure our integration tests are off. They are, and let's run our tests. So it probably should have 2 failing tests. That's okay. There we go, 2 failing tests. This one here, we should set this to connected false. That'll get that one to pass. And then we need to make sure we unsubscribe to call the subscriber. Unsubscribe to closed, callback, and there we go. Let's see here, all passed. One thing else we probably need to do is when we close it, we should probably shut some of this down, like maybe the buffer input. We could probably hold it open. It might be okay. It's kind of a question of even if you close the socket, there's still technical data in the buffer. That's a possibility. I think I'm going to go with if there's data in the buffer, we should clear out during close. So we'll do that. So test function, should clear buffer on close. And so we'll do, so we're going to connect to the socket and check out one of these down here, which is some of the reading, like so, like that. And then we're going to search. Oh, I already did that. So now what we're going to do is going to do the socket stream close, and then the bytes available should be 0. And so that'll sort of validate that the stream was cleared out. So we're going to run that. We're almost done with this class. It's a pretty beefy situation. It's pretty important that our socket stuff is working. So here we're going to make sure that maybe we should just set everything to basically null. We'll do our buffer input is null, our buffer is null, and then our input is null, and our output is null. Let's just clear most of that out. In fact, I'm going to create a private inline function clear buffer, and we're just going to use this and put that in there as well, clear buffer, and there we have it. So we should be able to run this. That should pass. And you'll see why I did this clear buffer shortly. So it's not just a mystery yet, or it's a mystery right now. So what we're going to do is we're going to, I think we have a clear function too, by the way. Yeah. These are just some like convenience functions I thought of. Probably not going to be used right now, but clear could be pretty good. We'll leave it blank for now because I'm the way I'm nulling things out versus just clearing out the buffer. Two different things, so we're just going to stick with what we got. Should subscribe to data. So what we're going to do is we're going to grab this bit here. Boom. Okay, and subscribe to data received. We'll just received. And now we're going to connect to the socket. We're going to set up this. Boom. And I think what we're going to do is just dry that up a little bit. Ignore cover, our F, clock, sample, data. Do that. And I think that should be ample. We could technically inline it, but we'll take that out and test anyways. So now, go here. And we're gonna, what do we call that function? Oh my gosh, we're losing my memory. Mock sample data. Okay. Mock sample data. There we go. I'm going to go up here. We're going to do the same thing with this, just to dry this out a little bit. Mock sample data, and we're going to mock the sample data right here as well. Boom. Okay, so now we should be able to assert our equal one callback count. Because if you look at the mock sample data, it actually calls update. So that'll happen. Let's go to, oops, we don't need that. And we're going to run our tests. Should have one failing test, or 261. So let's do that. And our failing test. I'm going to go up here to subscribe to data. Data is fine. And so we need to put this over here. Data. Data. All right, we're on business, and now we're going to do on the update, subscriber, notify data. And now we should have some passing tests. Not enough arguments. Data, this, in a array. And survey says, boom, okay. Another test to go is going to be there. Here. Test should unsubscribe data received. There we go. And we're going to just use this one here. Do that. And we're going to input.set there. We're going to socket stream unsubscribe data received, call back. And now we're going to lock some more sample data, assert our equal, our callback count should have not changed. So let's let that happen. Get our fail to happen. There's our fail. And just pass that right back in there. Oops. And we have one test that I know of left that we need to finish. There's that. And I'll do this last. Why not? We'll go right at the bottom. I'm going to say should dispose socket stream. Okay. So now we're going to get rid of all this goody stuff. So we're going to connect to the socket. We're going to do mock some sample data, and we're going to socket stream. We're going to subscribe to connected, and we're going to subscribe to close. We're going to subscribe to data received. So got a lot going on here. And then we're going to do, let's see here. That's all we need. So socket stream dispose. So there we go. So what are we going to assert? So I'm going to do this. Make sure all this stuff is null. This is why you should always work against interfaces. Just for, you don't want to be grabbing into stuff like this and knowing more about the implementation than you need to. Sort of, some ways anti-OOP. Like we could make these protected, which doesn't really exist in hacks or JavaScript or anything like that. So I just set them public. Debatable whether that's a good practice or not. I like it just because I always program against interfaces, and I don't really like to convert back or forth. I think that's dangerous. Unless there's a really screaming reason I need to, and I know the specific implementation, and that class is specifically tied to it. You know, there's a tight coupling there. But generally speaking, I stay away from it as best I can. Is null. I'm going to do socket stream. What I'm going to do is I'm actually going to split screen this so we can see our public stuff. Subscriber. We're going to make sure that our input, our output, our buffer, and our buffer inputs. So I just realized something. Our init actually sets at the input output. So on this, the clear buffer, we should actually not do that. So, because that will not be recreated. Something else we should probably do is when we clear the socket on close, somewhere in here, right here, no, I think we'll be okay. Okay. Yeah, okay. Stick with that. So that is all null. Assert is false connected. Socket stream. So make sure we disconnect when we dispose it. We don't want to have that held open. And I think we got a couple of other things going on here. We got to make sure this stuff is set to null. So socket stream, socket, error manager, object creator. So that's all looking pretty good. And I think I'm happy with that. So let's run our test. There we go, fails. Got a couple of these we can just toss in right away. Subscriber, it's null, input output, buffer. Actually what we can do is we can do the buffer that first. I just want to make sure. Okay, buffer, okay. Socket is going to be null. Error manager is going to be null. Object creator is going to be null. And clear buffer, actually should probably just do close. And that will do it. So if it is connected, I'll clear that out. Okay, so what we could do, yeah, that's fine. One thing I just want to make sure is our map subscriber is actually being created by the object creator dispose instance subscriber. Since it created it, it should destroy it. We still need to set to null anyways. And that's looking pretty good. Okay, so let's do object creator dispose instance subscriber. Make sure that happens as well. And let's see how close we got. All passed. Woohoo! So it feels good to have a green bar. All right, so let's just for good measure, let's make sure our integration tests work. So we're going to head on over to our Elixir. We're going to set up our integration and run our integration on our front end. And everything should pass nicely. Yes, we're all passed up. Passed out, passed up, I don't know. So let's go back over to here, git status, git commit, added subscription, and dispose, and clear buffer functionality to socket. There we go. Oh, we're not done yet. So what we're going to do is we're going to set up the way we're going to handle our input and output of our data. And so what I'm going to create a new package, and I'm trying to decide how I want to call it. We could call it data, but that seems too broad. We're just going to call it handler. Maybe we can think of something better. I'll take any suggestions. We're going to create our input handlers, and we're going to make our output handlers. And how this is going to look is we're going to get an input. This is the stuff that we receive from the backend. So the output is what we're going to be sending to the backend. Input is what we're going to be receiving from the backend. So one of the things we're going to receive from the backend is, like player connected. So we'd want to know that a certain player was connected. So we're going to create that. And so what we're going to do is we're going to set up some sort of interface here that's going to be used across. So one more we're going to create a one that's going to be like unit created. And so that's going to be when an actual unit is created. Now we don't see any commonality between these two yet, but we'll get there. We're going to create one more class in the handler level. We're going to call this, we'll call it IO handler. input output handler. One of the things we're going to need to get our command ID. This is going to be a getter. Null. That won't change. So this is how this is going to work. Is that we're going to get this command ID, and that's going to map to how we're going to handle that data. So we're going to get, in this case, this is an input, so we're receiving something from the back end. We're going to receive like a number like 1 or 20, and that's going to map to a particular class. Let's say in this case, we're going to implement IO handler, and that's going to connect up the command ID to player connected. I'll show you how this is going to work. So I'm going to add the command ID. This is going to be a getter and null here, okay? And get command ID. And this is going to return our command. So this one actually we can hard code, and I'm just going to actually put it up here. In fact, we could actually, because of hacks, we've got inline. So we're just going to create a high-level thing. We're going to call this I don't want to use the word battle, because that's kind of what's going to be happening, but that's not true all cases. So we're going to just call them commands, I suppose. Like, it's really, really broad. That's the best I can come up with at the moment. So public static inline function var. We'll call this player connected. This is going to be a int, and we're going to just make this 1. What we could do is make them. We're going to say this is our input commands, and here we can call these our output commands. And we could sort of make it kind of clever. We'd say like anything that's input is prefixed with 1, anything that's prefixed with actually probably do like 1001. So anything that's 2, it's a output. We'd say connect player, something like that. So we could do that. I think I'm going to pass, probably because we probably want to try and stick toward shorts, or even just bytes. 120 or 256 commands should be plenty, and we could change it later. So I'm just going to stick with this. We're going to say input command. We're just going to start with 1. We're just going to increment, because this is the most amount of, I wouldn't say, space for our thing. So the plan here is we want to send as little data as possible to the front end or the back end. So in this case, if we want to send our command ID, we'd want to send a byte. This is the smallest possible thing. Actually, ideally an unsigned byte. So here we're going to get our commands, and this is going to be player connected. In fact, I think I'm going to change this to IO commands. So now we get the player connected, so we know that's going to be a 1 whenever we want another command ID. Next, we're going to need the total bytes of this particular command, and this is going to be a getter as well. And this is always going to be an integer. In fact, it's going to be a U integer. Probably change that for both. And now, change this here and here. In fact, we could probably keep this null. We could probably do never. I don't know if there's any sort of performance thing on that for sure. Never actually looked into it. We'll stick with null for now, just in case. Next, we're going to do total bytes, and we're going to get the total bytes, null, and what we're going to do is prf get total bytes. And this is another great hackable thing, is we're going to create a new, actually probably stick this at the constants, byte values. There we are. So we got byte, short, float, boolean, int, double, long. So we have all these all ready to go for us. So what we can do is when we get a player connected, we're going to want to receive a certain number of bytes. So the first thing we're going to get is we don't actually consider the command as part of our input. So right now we're just returning 0. And last part of our IO handler is we're going to say function read, and this is going to receive a stream, input output stream, and this will actually pre-populate this IO handler. And it's going to be void, and we're also going to have a write. And in many cases this won't actually be implemented on both sides, but I'm just going to have it there just so it's convenient. It could potentially make them two different interfaces. I find that a little excessive. We could make this a base object. This is one of those weird cases we're not going to make it a base object, because ideally we don't want to be reusing these too much. We just want to have them overwriting the current data. So what we're going to do is we're going to put this little cluster together. We're going to bring the new down. We could make these base objects, but it kind of adds a little bit more overhead to it. This stuff needs to be really, really fast. So now, I think the thing we're going to need is public var. I think we're just going to need a player ID. And we're just going to make this a int. And what we're going to do is just store that. I think that's the only thing we need for now. This is, of course, it's going to grow as we go. And so we're going to read a unsigned integer. Okay? And then write, we have to do stream write byte, right, unsigned byte. And that's going to be our command ID, because we do have to write that back, and then write unsigned int, and this is going to be our player ID if we need to write out at some point, okay? And now our total bytes will be a single unsigned int, which is byte values, int, like so. We could, nothing's stopping us, just use the number 4. There's nothing stopping us. But this way we can kind of get a better look of, like, when we have more of these, we can do int, float, byte, whatever. And I'll show you that in just a moment when we do like unit creator or unit move. So this is not a unit in the game. This is the actual player is connected to the game, and we're tracking it. We get their player IDs, so we know what to do with them. It's also a full read-write. I'm okay with that for now. We want this to be pretty fast. Okay. We're going to do our unit created. This is going to implement IO handler, and we're going to create all of our stuff here. I can move this down. Of course, we want that. And this is going to be a get and a null. This is also going to be a get and a null. And I think we're missing, no, we're not. Okay, so get our two getters. Public. Actually, we could do private on this one. and command ID is going to be IO commands. This is going to be what about unit created or create unit? I'll stick with unit created since that's what I started with. Unit created. This is going to be very game specific. Created. I'm going to make that a 2. And our total bytes. So in this case we need to define what it's going to be. So I'm just going to return 0 for now. And we're going to read, what do we need? We're going to need public var, we're going to need player ID, with what player it's associated with. So that's going to be an int, public var unit ID, int, and probably need to put a position in the world. It's going to be an int, public var, and their y position in the world. And then we're going to set their rotation, so which way they're facing. That's going to be a float. Okay, that should be all we need for now. And this is where this is going to kind of come in a little bit clearer. So let's, I think that's all we're going to need. Because with the player, we can find out what team they're on. The unit ID, so we can track what unit is. I think that's going to be good. So what we're going to do is we're going to read the player ID. And this is, and it has to be in this order, back and forth. So we have to verify this. We have to make some integration tests for this. So stream, and we're going to read. We're going to read an unsigned int on that one because we could have lots of player IDs. Unit ID is definitely going to be a read unsigned. Oops. Read unsigned int. The position x is going to be a unsigned int as well. Stream read unsigned int. It's going to be the xy location. Rotation stream read float. And there we have that. I think we may have had an issue with our integration test. Let's do our CPP input. So we might have to really figure out this float issue sooner than later. We have unsigned int is actually an issue right now. So we need to figure those out right away. Reading float is okay. Reading a double is okay. So our reading int is a problem. And I want to know why real quick. It might be because our buffer input doesn't support it. Read, let's see here. Oops. Read, we do have a read int 32, so we actually have a problem with it in the bytes input. So we're going to have to write an integration test around that. And in the meantime, let's go back to our unit created. See, I told you to be going back and making those other things. Here, we're going to actually do stream write. This is going to be a write byte, a command ID. Stream write unsigned int, which is going to be our player ID if we need to go write out. This is probably not that necessary, but it's more of just the because we do have output. We have point at the screen. We have output commands which will handle these. So I'm just going to ignore these. It's just extra typing that we don't need to worry about. So now we're going to be doing everything that's not the command ID. So we're going to return a int. I wonder if we could do this. I don't use this very often. Using byte values. I think we should be able to do that. So we can say int plus, that doesn't seem to be picking it up, so I'm going to ignore that. Alright. Byte values. So we're going to have an int which is 4 bytes. Byte values dot unit ID, which is an int. Byte values int. Oops, these are should be pluses. So here's a possible, we have to check into this. Slowdown here. One gain to this is that it's a lot easier to read, maintain, and this is one of those things that needs to be perfect or it will fully break. But every time we get total bytes, it's got to do this math every time. We can maybe turn this into a macro if it becomes some sort of performance issue. And might even just do it anyways, just because we can. But just to double check here, we've got 1, 2, 3, 4, 5. So int, float, int, float. Okay, so we're good. And so we're going to stick to that as our day Monday on this. I'm going to make sure that we get a player connected and that we get a unit that's created. That should be our minimum for now. One more we're going to do later is the moving. So, and then we're going to have an output that we're sending to the server, and they'll move them for us. So, should come together. So we're going to go back over here to our source code. We're going to say git commit added input and output data handlers, and git, I'll just do date first, git push origin master, git tag 2016 0523 at 0849, git push origin, and there's our day there. So we're getting closer. I'm getting excited. As soon as we start getting units moving on state on the game, things start getting real fast. So we're gonna call it a day for now, and I'll see you guys tomorrow. And it's gonna be an exciting week.